Simpson here at Quant International in London. Joining me now is Julien Guyon, Professor of Applied Mathematics at École de Ponts. Thank you very much for joining me today.
Thanks for having me, Joanna.
Could you tell me a bit about your work on the joint S&P 500 VIX smile calibration and what challenges you're encountering?
Calibration is very important in quant finance when you price and hedge derivatives. So the option prices, they give you what are the expectations of the market participants about the future distribution of the S&P 500 for S&P 500 options at different dates in the future. And so people have looked into models that are calibrated to those option prices for decades and work well. But since 2006, VIX options were introduced, and they actually also give information about the future distribution of implied volatilities of the S&P at future dates. So it's kind of going deeper into the information about the market anticipations. And so the natural approach for many quants was to look at the parametric models that were used as state of the art at the time. And they realized that all those models could try to fit approximately both the prices of S&P options and the prices of VIX options, but not both of them at the same time. And when you try to be better on one side, then that would deteriorate the calibration on the other side. And in fact, this is because those parametric models, they are too rigid. So there are two ways where people have improved this joint calibration. So one way is to actually forget about like parametric model, and you actually go non-parametric. So that means like more complicated models that are not easily interpretable, but that are very, very flexible. And that's what I did in 2020 in this paper published in Risk magazine. That was the first one to actually build a model that was exactly calibrated to S&P option prices and VIX option prices. So that was using like a minimum entropy calibration. So that's one thing. And then other authors have also continued in this non-parametric direction. And also you could also just try also to improve the parametric models, so make them just a little bit more flexible and to adjust to both markets, the S&P and the VIX. And for instance, that's what I propose with the path-dependent volatility model.
And regarding the path-dependent volatility model, in your presentation, you mentioned machine learning tools. Do you think this solution could have been found 5 or 10 years ago?
But hard to tell, but let's say this, so this path-dependent volatility model is an example of a model that's parametric, actually even Markov, so easy to simulate and fast to simulate, that actually can calibrate jointly to the S&P and VIX options. And then because it's a model that comes from an empirical study, it does not have necessarily a nice mathematical structure that allows you to compute things analytically. Like in the past, people have often introduced models because you can compute things in these models, like even though the model doesn't have the right dynamics. But I'm more on the team. We want a model that captures the real market dynamics, even if we cannot compute things analytically. And then now, precisely with the advances in deep learning, for instance, well, there are things that you cannot compute analytically, but you can just ask a deep neural network to actually learn the function that you want to learn as a function of the factors and the parameters. And so now it's becoming very standard. So it's true that maybe like 10 years ago, I wouldn't have come to my mind because there was not all this fuss about like deep learning. But now that deep learning is so common knowledge, then it's not a problem anymore.
And you mentioned the neural networks there. So given the evolution of technology in that space and machine learning techniques and AI, is that changing quant finance?
Well, it's changing everything. Like honestly, I do believe that it's like kind of equivalent to the industrial revolution of the end of the 20th, 19th century. So I think we don't really see how much everything is changing through AI, but it's really, really profound, and in all aspects of life. So in particular in quant finance, but for healthcare, transportation, and like like I think it's really deeply challenging. I think so. So also in quant finance for sure, and we're seeing it just just looking at the conferences like here, like Quant Minds, where you see like a lot more of the talks and streams that are about like AI.
And as you say, we're having this huge leap forward at the moment. How do you see AI impacting the sector?
Well, that's the thing that's interesting with AI and finance is that I think AI has the most interesting or clear, strong results in fields that are not finance, where there is more structure in the data, or the signal is more important compared to the noise. Let's say in finance, the ratio signal over noise is actually very small, like this, quite a lot of noise, and precisely that's because of how the financial markets are organized and quite well at least arbitraged, and so it's quite difficult to actually get to beat the market, let's say. But we see like some hedge funds actually performing well, and it clearly is because of they are able to AI to actually see things that maybe others do not see, or so there is room, but it's interesting to see what it's going to be. But I think finance is probably one of the most difficult application areas for AI.
So given all this, how do quants need to change?
Well, anyway, quant, you do research. If you're a researcher, you have to adapt like all the time. That's kind of the nice thing with being a researcher, is that it's new every day, right? You're always trying to answer new questions, and the more questions you answer, the larger the domain of the knowledge, and actually the more new questions you have. So it's never ending. So in some sense, you always have to change and adapt, and so it's just. Of course, this might be like a bigger change than other changes, but it's just part of every day's a researcher to just adapt, and precisely like the researchers that maybe stick too much to one domain, or like and it can be a little bit dangerous. But so precisely you can just adopt deep learning and AI in many aspects of the quant work, and that's what many people actually do, because it works quite well. Yeah.
Big changes ahead then.
Thank you.
Julien Guyon, thank you very much for your time.
Thank you, Joanna.